we will do the irrationality of irrational number. This is the topic. So rational numbers can be represented in the form of Q upon Q, where Q is not equal to 0. P and Q are integers. Irrational numbers cannot be represented in the form of P upon Q, Q is not equal to 0. P and Q are integers. For example, 3 upon 5, 5, 7 upon 3, 3 upon 9. These all are rational numbers because they can be represented in the form of P and Q. Irrational numbers like pi is an irrational number, like 1.1011, like this number. The number in the root 3, root 5, and the root of prime number. They all are irrational numbers. They all are irrational. So we have real numbers, and real numbers are of two types: fifth decimal without decimal. With the decimal is again two type: non-terminating, non-repeating. Non-terminating, non-repeating, and non-terminating, repeating. Without decimal, the number without decimals are integers, like 5, 6, 7, 8. They are the numbers without decimals and they are integers. Sorry, not integer, rational numbers. Integers also you can say, or rational number also. Or you can say rational numbers. And the example of this 1.232323. The example of this 1.234539 and so on. This is rational and this is irrational. Irrational. So if I am representing rational with R, rational with R and irrational with I. Rational number with R, irrational. If I am adding rational with irrational, then the result will be irrational. For example, 2 is rational and root 3, and you will get the number which is equal to irrational. Rational plus irrational becomes irrational. Rational minus irrational equal to irrational. 2 minus root 3. Irrational minus rational, again irrational. Like root 3 minus 2 is again irrational. If you multiply rational with irrational, again you will get irrational. You multiply 2 with root 3, become 2 root 3, and 2 root 3 is irrational. Two root 3 is irrational. And if you are multiplying two irrational numbers, then either it will be irrational or it will be rational. For example, if you are multiplying root 3 into root 3, this is equal to 3 and this is rational. But when you are multiplying root 5 with root 3, then this will become root 15 and root 15 is irrational. Root 15 is irrational. So this is the idea about the rational and irrational numbers. We can represent rational numbers in this form, in the form of fractions, and we cannot represent this irrational numbers in the form of p upon q. So this is the basic idea about the irrational about the real numbers. So now there is a theorem in your 10th class. This theorem says that if p is prime, p is prime means p is a prime number, then P divides you can write this like if P divides A square, then P divides A. So what does this mean? What does this mean? Let's see. Like for example, if 2 is a prime number, this number divides not 2, you can take 4 here. 4 divides 100. 100 can be divided by 4, you know this very well. Completely. So means A square, this is A square means like 2 square equal to 4 means I can say 2 square divides 100, then we can say 2 will also divides 100. You can check this. 100 divided 2 equal to 50. This is the theorem. This is the theorem. And we will use this theorem for proving the irrationality of irrational number. So the question is prove that root 2 is irrational. We have to prove that the root 2 is irrational number. We know this root 2 is a rational number because I have already told you about this. The root of prime number is irrational, and now we have to prove, and this is the question that can be appeared in your examination. So there is a technique. There is a technique for proving root 2 is a irrational number or numbers which are in under roots. We will how to prove these numbers. Okay, so let's see. We will use here the method of contradiction. Method of contradiction. This is very different method. In this method, what we will do, first we will assume the given number as rational, and after that, after after that, the results will show us that this number is not a rational number. Okay, this number is not a rational number, so we will say that our assumption is wrong, so this number is a rational number. Let's see, you will know. Let root 2 is rational. So I can say root 2 can be written in the form of P upon Q, where Q is not equal to 0. And the one of the most important thing of the P and Q are co-primes. Azaan, I have already told you about the co-primes number, co-prime numbers. Okay, very good. Okay, so co-prime numbers are the numbers. You take two numbers and the HCF of those two numbers is 1, means those numbers are co-prime numbers, like 17 and 13 are co-prime numbers. So remember this co-prime. We will use this. We will use this. Now the story begins. We have assumed this thing. We have assumed that root 2 is rational, and if this is rational, so this can be represented in this form. You can prove any question like this: root 3, root 4, root 5, root 7, root 9, root 10, root 9 तो rational है, root 10, root 11. You can prove the questions like this in the same way. Now let's see. So we have this equation. So I am writing, we have this. So we have this P upon Q. So what I am doing, I am squaring both sides. Both side means LHS or RHS. So square both sides. So this will become square of this, and this will become square of this. So you will get here, when you multiply root 2 with root 2, square means 2 times multiply, it becomes 2. This becomes 2 and this becomes P square by Q square. So I can from here I can write Q square equal to P square by 2. Q square is equal to P square by 2. Now see here. What does it mean? What does it mean if it is written like here? Means 100 divided by 2 is equal to not 100. We can take some another example. Like you can take 100 divided by 2 is equal to 50, and this is square of this number. So what does it mean? It means that 2 divides 100. 2 divides 100. The meaning of this, the meaning of P square by 2, P is integer, P is an integer. The square of integer is again integer, and Q is an integer. The square of integer is again an integer. If you divide P square by 2, means P square can be completely divided by 2. This is the thing. like here you can see, like 10 by 2 is equal to 5. So I can write 2 divides 10, or I can say 10 is divided by 2 or 2 divides 10. The same meaning is same. So here you have to understand. This is the most important part of this. So from here I can say, from here I can say from this equation number 1, I can say 2 divides. Actually, we are getting some value q square after dividing this p square by 2. We are getting some integer value, means this 2 is dividing this p square completely, means 2 divides q p square. Two divides p square, and according to our theorem, if two two if a number divides, written right here correctly, if 2 divides 100, then 2 divides 10, means if 2 divides 10 square, it means then 2 divides 10. This is the case here. Okay, so this is our theorem, means if a number p, you can imagine any number which is dividing a square, the square of any number, then p will also divide under root of that number. Okay, like for example, you can like I am saying 5 divides 10 square. 10 square, so it means that 5 will also divide 10. This is our theorem. 10 square means 100. Divide करके देख लो, 100 divided by 5, completely divided, 20, 20, and this 10 by 5 is 2. 10 by 5 is 2. So 2 divides p square, it means that 2 can also divide p. It implies that 2 divides p from theorem. From this is the use of that theorem here. Now, if 2 divides p, 2 divides p, so I can write if 2 divides p, means 2 is the dividing p completely. When you divide p with 2, you will get a number, you will get a integer, but you don't know what is that number. So I am supposing that number is c. Let, so from here you can write p equal to 2c. P equal to 2c. So p is equal to 2c. Okay, and c is again an integer. Integer means 1, 2, 3, minus 1, minus 2, minus 3, minus 5, like this. Okay, Azaan? Azaan, please note it down till here, and when completed, can tell me. Take your time. These are very important things, and please note down these things correctly. Then we will move forward. You can ask me either to scroll up or scroll down. If anything left, then you can ask me to scroll up. Okay. If you add 2 rational numbers, then you will get the rational number. You can take the example like rational numbers. Okay, fine. This is the theorem. If P is prime, P divides A square, then P divides A. This theorem is used, and P and Q we know that are integer, and again P and Q are co-primes. Co-primes means the HCF of P and Q will be 1, nothing else. Only one. We have considered initially root 2 is rational. We have assumed that root 2 is rational. So root 2 can be represented in this form if this is rational. We have written earlier. So what I have done, I have square on both sides. I have done square on both the sides, and I got this result. And from this result, I can say q square can p square can be divided by 2. So p can also be divided by 2. This is the best method to prove the irrationality of these kinds of numbers. But you have to remember few steps. You will do one or two times you will do this question, then you can do a question similar to this very easily. Now we have p equal to 2c. P equal to 2c, and c is an integer. C is an integer. So you can consider this as equation number 2. Equation number 2. When completed, please tell me. Here, if 2 divides P, means P is divided by 2. Okay, good. Means P is divided by 2. So if P is divided by 2, we will get some number, we will get some result. So we don't know the result, so we have considered C. And C is an integer, so we have considered this. This is the equation number 2. This is the equation number 2. So now what we will do, now what we will do, you should write it like this is equation number 1. Please change this, and this is not an equation, so leave that. So this is equation number 1 and this is equation number 2. Now what I am doing, substitute P equal to 2C in equation 1. What is the equation 1? Equation 1 is root 2 is equal to P upon Q. Root 2 is equal to P upon Q. Instead of P, I am writing 2C. So this will become 2C upon Q. So Azaan, now again I am squaring both sides because here is under root. We have to remove this under root. So squaring both sides. So you will get 2 here, 4C square divided by Q square. And from here, when you cancel this out, you will get Q square divided by 2 is equal to C square. You will get this from this equation. Okay, you can solve like this. You will cancel this out. Here is 2, here is 1. This will cancel out. Here 2C square by Q square. So I can multiply this like Q square is equal to 2C square. So I can write C square is equal to Q square upon 2. This is very simple calculation. You can do this by yourself. That's why I have written here directly. So now from this statement, we can say that Q square is divided by 2, means 2 divides Q square. And after dividing the Q square by 2, we are getting some integer, means we are getting some result, means we can say 2 divides Q square, and it implies that if 2 divides Q square, then 2 divides. This is the theorem Q also, from theorem. In first time you will think this is the very lengthy method. When once you have done this 2 times or 3 times, this will be very easy. Okay, so from here I can write if 2 divides Q, if 2 divides Q, means Q divided by 2 will be some number we don't know, and I am considering that number D. Now question is solved. Here from here Q is equal to 2D. From here Q is equal to 2D, and this is equation number 3. Equation number 3. Now from this is equation 2, P equal to 2C and P equal to 2D, Q equal to 2D. From equation from equation 2 and 3. What is equation 2 and 3? P is equal to 2C and Q is equal to 2D, and C and D are integers. So Azaan, what is the LCM of P and Q? Write in the chat box. What is the LCM? Sorry, not LCM, SCF. Not LCM. Very good. जब कोई स्टूडेंट आंसर देता है ना तो मुझे पढ़ा लगता है कि मैं पढ़ा रहा हूँ, नहीं तो कोई फायदा नहीं है। सो अगर 100 क्वेश्चन मैं उससे पूछ रहा हूँ और उसने एक भी बता दिया तो मुझे ठीक लगेगा। ओके, सो लीव दैट। 2 is SCF. So HCF of P and Q is equal to 2, but we have no, we know that P and Q are co-primes. So if P and Q are co-prime, then HCF cannot be 2. We know that SCF can only be 1 if P and Q are co-prime. If P, Q are co-primes, then HCF of P and Q can only be 1. It means that our assumption is wrong. Our assumption is wrong. It means that root 2 is not a rational number. So we can say it means that our assumption is wrong. What we have assumed? We have our assumption is wrong means our assumption was root 2 is a rational number. So we were wrong. What is right? So we can say root 2 is what is the right statement? If a number is not if a number is not irrational means it will be if a number is not a rational, here we have considered this as rational, this is not rational. So what is the right thing? What is the right thing? Right thing is root 2 is irrational, and the most important, hence proved. Okay, Azaan, so this is the way of you have came late today also. I don't know why you are coming late. You are coming why you are getting late these days. Earlier you were on time, so you please note it down. Okay, that, but you should have a timetable. Okay, because यहाँ तक नोट कर लिया था ना, अब एक काम करो. सो वेरी गुड. हाँ, तो यहाँ से आप नोट करो. Substitute P is equal to 2C, and this is the best method. So आज तो इतना ही हो पाएगा इस क्लास में. ओके, अपने पीछे हो जाएंगे ऐसे काफी. So please ask me to scroll down. And we have 24 hours in a day. And if we are doing masti, means enjoying for 10 hours, so and sleeping for 10 hours, then also we have 4 hours. And in those 4 hours, suppose we are eating 2 hours, then also we have 2 hours. So these 2 hours we should at least study or revise our notes. Okay, please note it down. I am having a next class. In the next class, we will solve some more questions like this. Each and every word that I have said in this class or in any class is very, very important. If you follow this, you will get 100 out of 100 in mathematics or physics. Should I scroll down? Okay. So the main thing is here, if two numbers are co-prime, then we know already that is the only reason I have told you about the co-prime numbers, because I know I will use this concept here. So co-prime numbers are the numbers having SCF 1, but here P and Q are co-primes and SCF is 2, means P and Q will not be the co-prime if SCF is 2. So our assumption is wrong. यहाँ पे खुद को ही गलत प्रूव करना है अपने आप को. We have to prove ourselves wrong. We will solve some more questions like this, then you will get into the process. Done. Very good. So Azaan, please try to come on time in the next class. And okay, now you can leave and please revise your notes. And if you have